Hey guys, today I'm going to be covering sections 3-1 and 3-2 from our math book. So let's go ahead and take a look at the first one. Exponential functions. An exponential function looks like this. F of x equals a times b to the x, when a is not 0 and b is not equal to 1. The parent graph 2 to the x looks like this. You can transform it by reflecting it, translating it, or expanding or contracting it, just like all of the other graphs we've worked with. It follows the exact same rules, except for this time, this is your parent graph. It has a domain of negative infinity to infinity and a range of greater than 0. As x approaches negative infinity, f of x equals 0, and as x approaches positive infinity, f of x equals positive infinity. It has a y-intercept of 0, 1. And if you want to find the y-intercept of a transformed graph, all you have to do is make x equal to 0 and then solve for x. Now let's see how this applies to the real world. When you have money that's gaining interest, the amount of money you have increases exponentially. To see how much money you'll have after a certain period of time, just use this equation. A is the amount of money in the bank after t years. P is the initial investment. R is the interest rate. T is the amount of time that's passed in years. N is how many times per year it's compounded. Let's try an example. I have a friend named Inambola who has some questions about an investment she's making. Let's try to help her out. That's a good question, Inambola. First, we need to recognize that it's compounded quarterly and not continuously, so we'll be using this equation. The initial investment P is 1,000, the interest rate is 0.07 because it's 7%, it's compounded 4 times per year, and we're going to leave it in the bank for 5 years. Now all you have to do is solve it, and the answer is 1,414.78.
0.78 chickens?
Now, Inambola, I know you're really excited about your chickens, but you can't have 78 100ths of a chicken now, can you? You're only gonna have 1,414 chickens, which is still a lot.
Huh?
Let's go ahead and move on to the next topic. This is a log. This is a rhythm. And this is a logarithm. I know, not what you were expecting, but it's what we're going to work with. A logarithm has a base, which is b in this equation, and an argument, which is x, and is set equal to something, which is y. To be able to work with logarithms properly, you're going to need to know how to change them from logarithmic form to exponential form. To do this, just take the base to the y and set it equal to x. I like to remember this by comparing it to a middle school relationship. The base is Bailey, the argument is Aubrey, and y is Johan, the suave foreign exchange student. And do you know what Bailey likes more than foreign exchange students? Not Aubrey, so Bailey goes to Johan and leaves Aubrey all by herself. To change it from exponential form back to logarithmic form, all you have to do is make Bailey a good friend and reverse what we just did. Now let's talk about some of the basic properties of logarithms. First off, the base cannot be equal to 0 or 1. Log b of 1 equals 0. Log b of b equals 1. Log b of b to the x equals x. And b to the log b of x equals x, and x will be greater than 0. I know that this all sounds really confusing, but let's try to put a few real numbers in there to make sense of it all. Log 5 of 1 equals 0. That's because log any number of 1 equals 0. Log 5 of 5 equals 1. Log 5 of 125 equals 3. That's because 125 equals 5 to the third. So it's actually log 5 of 5 to the third, which according to our rule would just be 3. And finally, 5 to the log 5 of 2 would just equal 2. Now sometimes a log can look really crazy, like one of these two. If a log doesn't have a base, then we assume the base is 10. So the first one is actually just log 10 of 10, which is 1. ln stands for natural log, which is just log base e. So the second one is actually just log e of e, which is also 1. And if all else fails and none of these rules help you figure out what the log equals, then all you have to do is just plug it into your calculator and see what it is. Because after all, a log is just an actual number. And since logs are numbers, we can also graph them. The parent graph of a log is log 2 of x, which looks like this. You may have noticed that this is just the inverse of the parent graph of an exponential function, 2 to the x. That's because logs are the inverse of their exponential counterpart. Because of that, our log's domain is greater than 0, and its range is negative infinity to infinity. And the log doesn't have a y-intercept, it has an x-intercept at 1, 0. And just like I said with the exponential functions, logarithms are not really that hard to graph. That's because all you have to do is just transform the parent graph according to the rules that we've been using all along. It's really not that hard. And that's all for today's video. Thank you for watching. Hello guys, today I'm going to be covering chapter... the parent f of x approaches 0 as x... the y-intercept is... This is annoying. It has a y-intercept. Okay. Let's try an example. I have a friend named Inambola who has some questions about an investment she's making. Let's try to help her out. Did that start to go off while I was talking? Let's try an example. I have a friend named Inambola who has some questions about... It sounds like Ebola so much. I have a friend named Inambola who has some questions about an investment. A logarithm has a base, which is... To be able to work with logarithms properly, I know this all sounds really confusing, but let's just try to put a few... And if all else fails, and none of these rules help you figure out what the log equals...